All right, let's take a look at next section. We're going to break this into several pieces. So let's call this 5.2a. Start off the properties of rational exponents. Rational exponents are exponents that are fractions. So to be prepared, let's review all of these properties. I want everybody to take a moment, look through each one of those, and look at the example that's next to it, and refresh your memory on how all of these work. And then we're going to use the same rules and apply them to exponents that are fractional instead. And we will also keep in mind, moving through this section, the components of the last lesson. Okay, let's move on to some examples. Let's do part A. So we want to use the properties that we just studied to simplify each expression. So in part A, you're multiplying two bases that are the same. So what do? Yeah, we add exponents, don't we? So there's your answer, everybody. What you would do is you would add 1/4 and 1/2 together, which is 3/4. Now, whether that requires you to use a calculator or not to get those exponents added correctly, that's up to you. Now, resist the temptation to just type these into your calculator because eventually we will be working with exponents that may be variables or bases that are variables, and a calculator will then be rendered useless. Let's go down to part B. Okay, how would you go about doing something like that? Okay, well, what I think I would do in the first step is remember that all these properties are actually reversible. So this is kind of the power of a power rule where you're going to break this multiplication apart. It's almost kind of like a distributive property too, where this 2 is going to be distributed as the exponent of both of those terms. And then if you recall, what you do next is these exponents will be multiplied. And then you can simplify that one more step. Just go ahead and multiply your exponents together. And that's as far as you can go. You think about that, 6 to the first power. It's just 6. Now you cannot actually multiply the 6 and the 4 together, can you? No, they need to be the same base to be able to use exponent rules. If that were 4 to the first power, we could do that. All right, let's go down to C. So how do you think you'd go about something like that? Well, it looks like a very similar situation, doesn't it? But the difference is we actually have two exponents of 5 that are the same. Now, there is a different way to go about this problem to get to the same answer. But if they're both exponents of 5, you can regroup this 4 and 3, and you're reversing a property at this point, which is a power rule, power of a power rule. And now you know 4 times 3 is 12. And now you see a power to a power, so you can multiply those. And that gives you 12 to the negative first power. And now you got to remember, what is the role of a negative exponent? It is a reciprocal. So that's really 1 over 12 to the first power, or 1/12. So these take some getting used to understand how to use the properties correctly. Let's take a look at a few more. How about part D? What would you do about something like that? Well, let's keep in mind that 5 in the numerator is actually 5 to the first power. So what we have in this case would be two bases that are the same. So you can subtract the exponents and you get your result. So we got to remember that law of exponents. When you're dividing two bases that are the same, you subtract their exponents. Let's go down to E. Now, if you look at this, do you notice that these both have the same exponent of 1/3? So I think we could regroup the 42 over 6 to the 1/3 power, and then it's still squared. And you know what 42 divided by 6 is. That's 7 to the 1/3 power, which is still squared. And then you have a power to a power, which means you multiply. And you will get more comfortable with these exponent rules the more that you use them. All right, let's go ahead and apply this and see if we can figure these out. Okay, I want everybody to go ahead and start working on these, and let's check your answers. All right, so number one, what would you do about a problem like this? Well, I notice that the two bases are the same. So to me, what that means is you can add their exponents together. Okay, now 1/2 is the same thing as 2/4. So this is going to be 2 to the, add those up, 5/4 power. Let's go to number two. What would you do about something like this? Well, I would remember that that's actually 3 to the first power. And if I'm dividing, then what I can do is I can subtract my exponents. So what's this answer going to be? Well, it's going to be 3. That's going to be 1 minus 1/4. That's going to be 3/4 power. And there we go. Okay. How about 3 and 4? Let's take a look at those. Let's try to work those out. Okay, in number 3, I think what I would do is I would look at this and say to myself, you know, I'm seeing a 1/2 power here. So I'm going to rewrite this as 20 over 5 to the 1/2, and it's still to the 3rd power. And then what I'm going to do is I'm going to think, okay, what's 20 divided by 5? Well, that's 4, right? So this is now 4 to the 1/2 power to the 3rd. And if you remember, the 1/2 power is a square root, isn't it? So this is actually the square root of 4 to the 3rd power. And that would be 2 to the 3rd power, which is 8. Okay, so now look, you could take a different route to get to that answer, but that's one way to do it. Let's go to number 4. Okay, take a close look at that. I don't see the same bases. I don't see the same exponents. So what I'm going to do is a power of a power rule. I'm going to multiply the exponent. I'm going to rewrite this. So this will be, of course, my cursor's in a way. Okay, this is going to be 5 to the 3 times 1/3 times 7 to the 3 times 1/4, which will be like 3 over 1. Those cancel. All right, this will be 5 times 7 to the 3/4. Can't do anything else with that as far as you can go. Okay, these are kind of small. Let's get these a little bit bigger here. Okay, let's go ahead and give this a try. Everybody try 3 and 4 now. See how you do on these. Okay, number 3.